Hello, my name is Victor. Welcome back to the Victor Learning Hub YouTube channel. Today we're going to be going through the power rule from the Jacaranda Math Methods textbook, specifically 11.4. And today our syllabus link is going to be use the rule of d of dx of x to the power of n equals n multiplied by x to the power of n minus 1 for positive integers. Alright, so when you look at that may not make a lot of sense. And what the textbook has actually given us is these three formulas that we need to use and work with to use the power rule in order to differentiate functions. But the main thing you just need to take out of this is that n has to be an element of natural numbers, and also when you're deriving a constant, for example here of f of x equals c, f dash of x is going to be 0. So this is just something important to take into consideration as we go through the problems. But honestly, looking at these formulas doesn't really help me use the power rule and understand it. Actually, practicing the questions gives a better understanding, which we're going to do right now. Okay, so let's try and differentiate this function using the power rule. F of x equals 3x squared minus 12x plus 2. Okay, so all you're going to do is you're going to look at the power of the variable x here. So x squared. After that, you're going to multiply the value of the power to the coefficient, which is 3. So 3 multiplied by 2. The same goes for negative 12x. So that's just x to the power of 1, and then 1 multiplied by 12. And for 2, it's a constant. So it's actually going to disappear, as it says here. So, for example, if we put x to the power of 0, remember anything to the power of 0 is going to equal 1. So 2 multiplied by x to the power of 0 is just 2. It's the same thing. Since the power here is 0, we multiply 0 to 2, and 2 multiplied by 0 is just 0. So that just disappears. That's why constants actually disappear. We just don't really see it. And when you do more of it, you just get rid of it basically whilst you do the question. So you multiply, so the coefficients by the value of the power. So that's going to be 6. And after that, you're going to subtract 1 from the power. So since the power here is 2, you're going to go 2 minus 1, and that's just going to equal 1. The same applies for here, 1 minus 1, and that's going to equal 0. So here actually it's going to be x to the power of 0, which is going to be 1. So actually negative 12x is going to turn into a constant. So you know that f dash of x is going to be 6 times x to the power of 1, because we know our new power now is 1, minus 12 of x to the power of 0, because we know our new power is 0. Then our constant, it just disappears, so we don't need to include that. And now we can further simplify this into f dash of x equals 6x minus 12. Let's move on to f. So f 10x to the power of 4 minus 10x cubed plus 8x squared plus 7x plus 1. So literally applying the same rule before, making sure we look at the powers of each variable at first. This will be x to the power of 1, x to the power of 0. We look at the powers, and after that, we want to multiply the value of those powers by its coefficient. So making sure we multiply those right there. And after we multiply those coefficients, we subtract the power value by 1. So f dash of x is 40x, because 4 times 10 is 40. And then it's going to be x cubed, because 4 minus 1 is 3. We're taking 1 away from the power of the variable x. It's going to be minus 6x squared. 3 times 2 is 6, x squared, plus 16x, or x to the power of 1, which is x, plus 7, because x to the power of 1 becomes x to the power of 0, which is just 1. And then just this constant here, it just disappears. So we know now that f dash of x is 40x cubed minus 6x squared plus 16x plus 7. So see here how we've really just looked at it and applied it. Looking, these formulas are correct, but they're not very useful and helpful in remembering what to do. Try and apply the power rule instead of remember it, and you should be able to do the questions a lot easier with better understanding by doing that. Okay, question 11, let's do this. Consider the polynomial function with the equation y equals 2x to the power of 3 over 3 minus x squared plus 3x minus 1. Calculate the rate of change of the function at the point 6 and 125. Okay, the rate of change of the function at the point. So if we are trying to find the rate of change of the function at a point, That refers to the instantaneous rate of change because only at that one point. So what we're going to need to do obviously is calculate the gradient function of this. So for ease, I'm just going to name this f of x. It's basically the same thing. Okay, so now let's multiply those powers by the coefficient. So 3 times 2 is 6. So it's 6x squared because we're taking 1 away from the power value over 3 minus 2 times x because x becomes x to the power 1 plus 3. And then the constant just goes away. Now we can further simplify this into 2x squared minus 2x plus 3. So there we are. We've got our gradient function. So now it wants to us to find the rate of change. So basically what it's asking us to find here is m, which is the gradient at this point. So if we know our point is 6 and 125, so we can actually sub in the value here of x equals 6 into this equation here to find the gradient at this point. So let's do that now. F of 6, so that's why I actually wanted to put f of x first, so we can clearly indicate that we're subbing x equals 6 here, so I can put f of 6 to clearly showcase that. It's going to be 2 multiplied by 6 squared minus 2 multiplied by 6 plus 3. That's going to be 72 minus 12 plus 3. Therefore, f dash of 6 is going to be 63. So voila, that is going to be our rate of change at the point 6, 125. Okay, great. So we've done part A. Now let's do part B. Calculate the average rate of change of the function over the interval x of an element of 0, 6. Okay, so instead of the rate of change at the point here, we're calculating the average rate of change, which I went through in the previous video. So all the question is asking you to do actually is find the y values at the points x equals 0 and x equals 6, and then just use the formula m equals y2 minus y1 over x2 minus x1, which you've used before. Okay, great. So let's go back to our original formula of f of x. So we know that we're going to try and find the y values at x equals 0 and x equals 6. So let's just do x equals 0 first. So f of 0 equals 2 multiplied by 0 cubed over 3 minus 0 cubed plus 3 times 0 minus 1. So this one's pretty obvious. F of 0 is going to equal negative 1, which that means that the y value at x equals 0 is going to be negative 1. Okay, great. Now let's do f of 6. So that equals 2 multiplied by 6 cubed over 3 minus 6 squared plus 3 multiplied by 6 minus 1. So 6 cubed, so 36 multiplied by 6. That's going to be 216. So 2 multiplied by 216 over 3 minus 36 plus 18 minus 1. Okay, so 216 divided by 3, that's 72. So 2 multiplied by 72 minus 36 plus 18 minus 1. 144 minus 36, that's 108 plus 18 minus 1. So therefore, f of 6 is going to be 125. So we know now that the y value at x equals 6 is going to be 125. Great, so now we can sub in these points, 6, 125, and 0, negative 1 into our equation. So we know that m is y2 minus y1 over x2 minus x1. So we know that negative 1 minus 125 is going to be over 0 minus 6. So that's negative 126 over negative 6. So therefore the gradient is going to be 21. Hence, the average rate of change across the interval of x of an element of 0 and 6 is going to be m equals 21. Okay, C. Obtain the coordinates of the points on the graph of the function where the gradient is free. Okay, so all this question is saying is to try and find the coordinates of the points, so points in terms of x, y, where the gradient is free. So basically saying where the function gradient of f of x is equivalent to free. So all we've got to do is actually sub in this f of x equals 3 into our equation right here. So let's do that. Okay, so we know that 3 equals 2x squared minus 2x plus 3. Okay, so we know that the 3's cancel out right here. So that's going to be 2x squared minus 2x equals 0. Okay, great. Now let's just solve for x like a quadratic with the null factor law. So 2x is a factor outside, which is going to be multiplied by x minus 1 equals 0. Therefore, x is going to be 0, and x is actually going to be 1 as well. Cool. So we actually have two possible values for x equals 0 and x equals 1. So there's actually 2 points where the gradient function is going to be free. So we need to find the y values for both of these. First, let's start with x equals 0. So we're going to have to find what f of 0 equals. We've actually done this here already with the average rate of change array. So we know that f of 0 is, the point there is going to be 0, -1. So f of 0 is -1, which means that the point is going to be 0, -1. Okay, great. Now let's do x equals 1. So we haven't done x for x equals 1 yet. So f of 1 equals 2 multiplied by 1 cubed over 3 minus 1 squared plus 3 multiplied by 1 minus 1. Let's make all these constants into denominators of 3 now. So f of 1 is 2 over 3 minus 3 plus 9 over 3 minus 3 over 3. That's going to be -1 plus 9, which is 8. 8 minus 3 is 5. Therefore, f of 1 is going to be 5 over 3. So that means our point here is going to be 1 and 5 over 3. Okay, great. So there we go. We've done C. All right, thanks for watching.